Okay, so in this problem we are going to be using the law of radiation. So let's give this problem a read. Suppose a person is unclothed and energy is being lost via radiation from the body's surface, which has an area of 1.45 meters squared, which has a temperature of 34 degrees Celsius and an emissivity of 0.734. Suppose that the metabolic processes are producing energy at a rate of 110 joules per second. What is the temperature in Kelvin of the coldest room which this person can stand and not experience a drop in body temperature? So I have the equation here that we're going to be using for this problem, and I broke down the temperature into the hot temperature of the body and the cold temperature of the room that they will be standing in. So what we're solving for here is the temperature of the cold room that they can stand in without experiencing a temperature drop. So what I'm first going to do here is algebraically solve for this variable here. So what we're going to do is we're going to divide the emissivity, this sigma symbol, the area, and the time under Q. So what it's going to look like, I'm just going to rearrange this so it looks, so we have the variable that we're solving for on the left. So it is going to be T hot of the body minus the T cold of the room. Make sure it's raised to the fourth for both of these. So that will equal Q divided by the emissivity, the constant, the Boltzmann constant, the area, and the time. And since this person is just walking into this cold room, it is going to be instantaneous, so we're going to say this is at time 1, so we're going to get rid of this time variable here. So the next thing that we want to do is we want to get this T cold of the room by itself. So what we're going to do is we are going to minus out 4 so then it will be and then the next thing is we just want this variable here. So what we're going to do is we're going to multiply both sides. Because this is negative, we're going to multiply both sides by -1. And so we're going to have to distribute this -1. And what's going to happen is we are going to have and I'm going to rearrange this because the -1 is going to make this part of the problem negative. So it is going to be the T hot of the body to the fourth minus the Q Okay, so now what we're going to do is we are going to solve for this part of the equation right here. And what you guys should get, just to make sure that you're on track here, is this value should come out to be something like 7.06 times 10 to the 9th. And this is rounded, but do not do any rounding when you're working with this. This is just to make sure that you're on the right track. So after you get this value, what you're going to have to do to get rid of this raised to the 4th is you're going to have to take the 4th root of both sides. So that will equal out to be the T cold of the room should equal out to be 289.86 Kelvin. And just as a reminder, we're given Celsius here, so what you're going to want to do for these temperature values is to convert from Celsius to Kelvin. So for the temperature hot of the body, it will be the 34 plus 273, which is equal to 307 Kelvin. And this is okay. Hopefully that helped.